Hi guys, so just going to give you a little intro to finding the area in a regular polygon. We know that from our previous unit that a regular polygon is a polygon in which all sides are congruent and all angles are congruent, right? So sides all have tick marks and angles all have rings. Okay, so if I want to find the area of a regular polygon, I'm going to have to I'm going to have to define some parts that we haven't learned about yet about a regular polygon. And these definitions are based off of this regular polygon being inscribed in a circle. So the center of a polygon, a regular polygon, is considered to be the center of the circumscribed circle. If I have a circle going around the outside of the shape, then the center of the circle is the center of the regular polygon. Radius is just what you would think it is. It's the distance from the center to a vertex, right? If it's going to go to the rim of the circle, it's going to have to go to a vertex of the polygon. A new term is the apothem, or some people call it the apothem, and it's altitude-ish, right? So in all the other shapes, we've had an altitude to represent our height for the shape, and the apothem is like that concept. What's different is technically an altitude comes from a vertex and is perpendicular to a side. So that's technically an altitude of this shape versus we're just wanting the apothem, which only goes to the center. So from the center to perpendicular to a side. Okay, and then this central angle is an angle whose vertex is at the center of the circle. So this angle right here, we know would be a central angle because her vertex is at the center of the circle. And so I can, here, if I draw in all my radii, right, to make a bunch of central angles, then I know all the way around, all of those central angles combined would add up to 360 degrees because it's all the way around a circle. Okay, so what you have here is an investigation for coming up with the area of a regular polygon. I'm going to let you pause the video and work your way through the investigation, and then you can unpause and double check yourself. Okay, so let's check our answers on the investigation real quick. So you should have had 6 sides. It's a hexagon. When the radii are all drawn in, there were 6 triangles, and that will always be the case. The number of sides will be the same as the number of triangles the regular polygon can be split up into. So how the triangles are all related? They're all congruent. What postulate supports your answer? I said SAS because my radii are congruent, and then my central angles are going to all be congruent because I divided them up evenly. 360 divided by 6 central angles, each one will be 60 degrees. But if you said, since this is a regular polygon, all the sides are congruent too, so you said side, 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 either one of those would work. Okay, then I drew in my apothem on each triangle, and this was my side. So if I'm going to find the area, let's see, draw the altitude, represent the height. What would the area formula for each individual triangle look like? So I said 1/2 base times height for a triangle. In this case, it would be 1/2 times the side length times the apothem. Okay, so if I add up all 6 of those, 1/2 apothem times side length for all 6 triangles, and then really I misspoke or miswrote your instructions. I didn't really want you to factor out the greatest common factor because they're all the exact same. Instead, if we can factor out the 1/2 times the apothem, then this is what you have in part 5. 1/2 times the apothem plus side times side plus side plus side plus side plus side plus side. And then, hint, is there a name for the sum of the sides of a shape? What is it called when you add up all the sides of a shape? It's called the perimeter. And that, my friends, is the area formula for a regular polygon. So, do we have a box? Here it is. It's on the 3rd page. So the area of a regular polygon is half, because it's 1/2 base times height for the triangles, the apothem times the perimeter. So 1/2 times apothem times perimeter. right? So apothem is this guy here, coming from the center perpendicular to the side. Perimeter is what all the sides together would be added up to be. And that's the formula, friends. So on this first example, you're just going through and figuring out if you divide this up into 3 congruent triangles, how much would each central angle be? You're just finding the angle measures on this first example. So 360 divided by 1, 2, 3 congruent central angles. Each one of those will be 120. So 7 would be 120. 5 is indeed half of 120 because that's an isosceles triangle. So it'll be the angle bisector in an isosceles triangle, which is also the altitude and the perpendicular bisector for that matter. And then you have a 30, 60, 90. So angle 6 would be 30 degrees. Okay, so do the same thing for B and U try, and then I'll let you try some of these other examples. The key is posted on Haiku, so you can check yourself as you go. I think the investigation may be a little bit different, but everything else in the notes should be the same. Okay, bye guys, see you soon.